I am Dr. Yasir Ali, and today's lecture is about polynomial interpolation. In today's lecture, we will be discussing basic material about curve fitting, interpolation, and polynomial interpolation. And the detail of the method listed here: Lagrange interpolation, Newton divided difference interpolation, forward and backward difference interpolation will not be covered in this short video. So let's start. Data is everywhere, and we have to use it to make decision in our daily life as well. The world is becoming more and more data driven with endless amount of data available to us. We have to make decision on it. Microsoft, Google are using concerning data to good effect, and we can do so. We can analyze the data to get some information, and we can use these information then to enhance our knowledge and wisdom, and then we can apply this wisdom to real world to to maintain or to enhance the quality of life on the earth. And it includes every field of life: medical, engineering, industry, economy. Everything has to decide upon some data. So how to analyze the data? To analyze the data, a mathematical tool is used known as curve fitting. Curve fitting is a process in which we try to fit a curve that gives us the behavior of the data. Depending upon the error or the amount of error associated with the data, there are the two approaches used in the curve fitting. Number one is the regression, and number two is the interpolation. Regression is a curve in which gives us the trend of the data, and in the regression we are not interested to intersect every point of the data. Higher polynomials may be used to interpret the data well, and there is the example of it. So we can use regression for curve fitting, and we can use interpolation for the curve fitting. The approach of interpolation is to fit a curve or the series of curve that passes through each of the point. As compared to regression, we have seen that in the regression, the curve does not pass through the data point. This is in the case of regression, that the curve does not passes through the data point. But in case of polynomials, curve need to pass through these data points. These curves might be piecewise continuous or continuous curves, but in case of interpolation, they must pass through the data points. So regression, when do you use regression? When we have low accuracy of the data, or the data points are very large, then the regression would be the best choice. But when we have high accuracy and we want to know the values of the function between the given data points, then we have to use interpolation. When we use interpolation, then most of the time we mean that we will be using polynomial interpolation. Why polynomial interpolation? There are two main reasons for it. Number one is that there is solid mathematical ground available in the form of Weierstrass approximation theorem. This theorem states that if we want to approximate a function f of x defined on the continuous, defined and continuous, and there exists some epsilon greater than 0, so we can find a polynomial, or there exists a polynomial with the property that the function and polynomial are, are very close to each other. We can explain this fact as, for example, we have a function and there is well-defined margin of error, well-defined tolerance. Then within this tolerance, we can draw this blue polynomial e of x. So these are the evidences, or these are the requirement for the polynomial, and we can approximate any given function with the polynomial. Another important reason for considering the class of polynomial is that the polynomial, when we take the derivative of the polynomial and we integrate the polynomial, it is easy to deal with. Plus, the derivative and the integral of the polynomials are also polynomial. So the theorem and this important reason that polynomials are easy to deal with, and the integral and the derivative of the polynomial are also polynomial, make it a suitable choice for approximating the function. Now we will try to explain, try to understand what is the polynomial interpolation. What do we mean by polynomial interpolation? The interpolation is a method to estimate the values of a data between two known data values. Means we have the knowledge of two values and we want to find the value in between these two values. This is the main objective of interpolation. For example, we have tabulated value for the air velocity between 0 to 1800, and there is a gap of 200 between these values. How can I find a value? How can I find the thermal resistance for a value which is not listed in the table? For example, we have 0 to 1800 values are listed in the gap of 200. So I can see the value for 0, 200, 400 up to 1800, but I want to calculate a value which is not in this table. Then how can I do that? I can do that with the help of interpolation, and using the interpolation I can get the estimate of this middle value. Here we will discuss about the degree of the polynomial and the data points relationship. We can see that there is only one and only one polynomial for of order n that passes through n plus 1 data point. We can start with a very well-known example or very well-known concept that a straight line can pass through 2 points, and there is only one straight line that can pass through 2 points. By the way, there a parabola, which is a second order polynomial, can connect 3 points. This is what I'm talking about. If I have 2 points, then a straight line, which is first degree polynomial, can approximate the value. If I have 3 data points, then a second degree polynomial can do the job. For 4 points, a third degree polynomial, and for 5 points, we can get a 4 degree polynomial. So this tells us that for a n degree polynomial, there should be n plus 1 data point, or for n plus 1 data point, we will have a polynomial with order n. So this is the interpolation problem, that for given n plus 1 nodes, x1, x0, x1 up to xn, means n plus 1 data point. For these n plus 1 data point, we have the functional value given, and there is an intermediate value x star. This x star is different from these n plus 1 value, and we want to predict the value of the function for this x star. So this is the interpolation problem. We can state it like this. A polynomial interpolation consists of determining a unique polynomial y is equal to p of x of the order n that fits the n plus 1 data point. So for n plus 1 data point, we will get a polynomial of degree n. Then we use this polynomial to compute the intermediate value. So this is the problem which we have to do in interpolation. Method which we will discuss in our next video are the Lagrange interpolating polynomials, Newton divided difference interpolation, forward and backward difference interpolation. So if you have any query, comment, you can email me on my email address. Thank you very much.